András Tevesz is going to be speaking to you. He's speaking here for the third time at Hacktivity. Many of you know him well. All those who don't know him, I'll tell you that he is into extreme sports, and that is what he does with virus, antivirus products and root kits. He will tell you what he's capable of in the field of. Okay, now you can hear me also. Okay, we've done the introductions already. First of all, I'll tell you about my motivation. I predominantly deal with IT security audits, and doing penetration tests. I've come across antivirus programs. Of course, you get into a machine, you can actually run codes on it, but there is an antivirus program running on it that actually stops us. So we find it difficult to actually, for example, save passwords. We cannot put up a rootkit or a backdoor, something on the machine. So one of the outcomes of these studies is basically the two presentations. Microsoft Security Essentials tool. It is an antivirus program. It's a very simple slide, and then we will talk about ESET, which is basically globally true for every single asset product. We have already announced the bug to ESET. It seems they will patch it. There is a hotfix that will be out soon. The first step will be, basically in ESET you have this built-in password protection. If you work for a company, you have the ESET antivirus on their machine and they set the password. From then on you cannot really bust your antivirus program, you cannot switch it off, you cannot switch the firewall off, you can only just accept the fact that it's there and it's doing something. In our cases, we cannot accept this when it's a security audit, so we have to find a solution for this. Usually they ask us not to, of course, bust the machine or to destroy the antivirus. So we have to find some sort of an audit mechanism with which we can switch it off. Unlocking passwords, we have moved on. What we do is we actually modify settings of ESET. We change the rules and there are possible solutions that I think might help us in workarounds. So Microsoft, the objective here was, this was actually a test case, that there was a Microsoft antivirus on the server and we tried to run codes on them, a Meterpreter and a Metasploit. We wrote the file on disk, antivirus found it and erased it. But then we found an alternative method. We could already run commands on the machine. There is a task kill command which allows you to actually stop any process whatsoever, to kill any task whatsoever. What we did here was we had MSSQL access. XP command shell allowed us to run commands. Of course we could not run everything we wanted, but we ran this command and it just stopped the whole antivirus, and from then on we could actually write anything on the server and run it. A bit of a video for you. We have the files in the sample library. We will copy the Meterpreter. We have managed to copy it. We wait a bit. And then the antivirus has found it. Basically what he's doing is deleting the whole file.
Gyorsan elindítjuk, hozzáférés megtagadva. Itt látszik, hogy a hozzáférés blokkolva van, tehát az, hogy ő lassan reagál, ez csak a látszat, azért ő blokkol valamit. Hát akkor mit tudunk tenni? Lelőjük.
So what can we do? What we do is we just kill the task, the process of this task. And of course what you're seeing here is an alert that there's a big problem, an important process has been lost. That really doesn't preoccupy us, we just copy our Meterpreter there we launch it and it actually launches without any problem whatsoever. That is quite a problem. And in this concrete case, when we tested it, we had a normal user. The user was probably working, and all of a sudden a red window pops up. They would have contacted IT. Everything, we started a run. We ran the process and it said it's completely clean. So basically here, of course, there's a very, very strange phenomenon within the antivirus. It has a service part and also a GUI display, and if you actually kill both, first the GUI and then the service, not much will happen. Basically it will not be looking, it will not be seeking viruses, but the icon will be there. So all processes have stopped, and we just copy our interpreter and we can start it. And that's so much for the antivirus. I would not have built a complete presentation on this, so that's why I think we should just move on. Bit of an explanation. Window comes up. It's not good for us, therefore we have to change the order of events. Meterpreter script has a killave script. I took out about 2/3 of the list. These are the antiviruses that you can actually now stop. You kill the process. Basically, an attacker comes in or a malicious code comes in, they can, without any problem, stop these antiviruses and many more. ESET is more important. That is actually a commercial product. It's much better chances. You just cannot stop a process here. What you can do is in Windows you have certain delicate areas. The registry, the other is the kernel driver for the antivirus, process access protection, and the service protection. So basically an antivirus means you have a surface, you have a service, and then you have a kernel code. Kernel code is typically very, very simple, dumb, it doesn't do anything, it just captures the data, sends it to service, and then the service actually does the actual processes, and then just says can it go or not. And if it cannot, then the GUI process informed, okay, let's show the guys some window, we have found a virus, what should we do? For ESET, we have to protect more things. One is, of course, registry, where the settings are, processes, what kind of rules there are, what kind of plugins should launch. And if we could write a registry, we could amend, for example, firewall rules. Kernel driver, if we stop that, then the whole screening stops. So nothing, no data will come up towards services, nothing will happen. For processes, if we could kill the process like we did with Microsoft, then we would be quite well off. Service basically does the same thing. So let's look at what we have.
Itt nem annyira olvasható, az ESET-nek a kulcsa látszik a registryben.
Here's the ESET key in registry, trying to establish a new value here. It doesn't really want us to, and most probably they have, when we want to write into registry, they are stopping us if we want to write into their part of the registry. The protection is not quite comprehensive. You can establish a new key, but the new key is...
Illetve nem tudunk ebben sem semmit létrehozni. Akkor nézzük. Megpróbáljuk, tehát megnéztük, hogy hogyan működik ez az egész.
So we looked into how this really works. There's this kernel driver, which is basically some sort of a device control file that allows you to access it. You can send IOCTLs here. This is what starts. It says we are starting again, we're restarting, we're stopping, something's going to happen. If we can send such messages, then there's a whole lot of things we can achieve. These are not documented things. We either have to look it up in reverse engineering, or we just have to use brute force to get them out. But the service itself does not allow us to open it, so there's not much we can do.
Kicsit meg vagyok fázva. Van ugye az EKRN Service-ünk, illetve a GUI processzünk, Őket megpróbáljuk ugyanúgy kilőni,
The EKRN service, well, we start to stop it, it says access denied. It didn't work.
Windows API-kon keresztül megnéztem.
Now, I use Windows APIs to see what I can do. Now, open process is to open any processes and try to do anything here. Our first move would have been to terminate the process, to terminate the GUI, but it didn't allow us. Then we wanted to make a new thread with a code that we like registry modification, but it didn't work either. Then we have a password protection, which I mentioned in the beginning. This is how it looks like, approximately. You just provide a password, and then if you want to modify anything, then it comes up. And you cannot uninstall the product, because again, it will ask for a password. Now, I couldn't find the password where it's stored. It is somewhere in the registry, but I couldn't find it. So let's see what we can do with it. Now, the demo here is going to be about setting a password. So this is a theoretic thing, because if we could run anything we did, but we couldn't. Now, we see the password. We cannot access the system. It is protected. Now we are logged in. Now we have a meterpreter script, and what we did here is that we just load the program and then generate the programs. We load it through the command line. You can see the code over there. And from this point on, there is no password protection. This can be done on any machine. If we have a local access, then it goes without problem. You just have to generate a code. I'll show you how to generate a code. Now, the old solution of ESET was the unlock v3. Now, this is a bit different than the new one. This is the old solution, but the essence is the same. The code is quite simple. It doesn't do a lot of things. It sends a code, then expects a code, and then based on that, it would write this value into the registry key. And then if the asset finds it there, then it will forget the old password. Now, in the old one, there was no registry protection, so this worked properly. In the new asset, you have a registry protection, so this would not work this way. Now, let's look at some specificities. Originally, the hash buffer, when this was running, it looked as if it was a hash code, but it's a CRC code, so this is just this is how it works properly. The code starts. This is unlock v3. It will ask the name of the computer. It will calculate a CRC. It will query the sector number, the offset, and all other figures and data. It will just add them up, and then it would put it together with the CRC value. This is what it writes down as a code. This is what we send to the asset. We get an answer. You can see that at the hash buffer code, and then there's a CRC calculation, and if this code is appropriate, then it is just written in the registry and the whole thing is unlocked. This is the newer version. You can see the description. I just downloaded part of the web page so that it should work this way to demonstrate how it should work. This is quite identical to the previous one. And this is where you see the differences. You see that the device I/O control call request, and also the, well, this is probably not the way it's originally named, but this is how I named them. And so if we have right to access the kernel, so we can open the file that we cannot open, then we generate the message, send the message, and with that message and two other messages, we can ask the asset to forget the self-protection, this silly thing with the self-protection, and not to want to protect itself any longer. So this is the essence. Access evaluation and the ICO control requests. Device IO control call, this is what it looks like. It is not a complicated thing that we are sending. 2224448, this is the IOCTL call number. So if we know this number and we know the second parameter as well, then this puts us in a good position. But we are still at the phase that only unlock.exe has access to the control file. So this is not good enough yet. This is again the algorithm re-implemented, which I reversed. I now re-implemented. I slightly amended the table because I didn't know that it was CRC. Now that I know, it's okay. And then the code generation re-implemented. We are querying the computer name. We hash it, CRC it. Now, our specific problem, what are the specific problems? Now, the code generation is on the client side, and the control is also on the client side. So, we don't need to go to the asset and to send this code to the asset because we can generate it ourselves after reverse engineering. And this is how we can reproduce the whole thing. Now, the license validation in the whole system works as follows. We send the license identification to the asset. They will check if it is an existing one, and they will send back the unlock code. In our case, it doesn't work because we didn't even send the code, so there is no online validation at all. The major problem is that this code is reusable. So once we generated it, as long as we do not replace our Winchester and rename our computer, we can use this code to unlock the machine anytime, or the computer of anyone else's, if he has the same disk and the same computer. Now, the other problem is that there is no timeout support. So if we get a code like that, then that is going to be valid endlessly. It is easily reproducible. This is what we've done, and it works. But we had the IOCTL, the EOCTL thing in the code. In order to be able to write the registry key, the protection has to be solved. The protection has to be opened. Now, the three calls, if we carry out those three calls, then specifically the whole self-protection is forgotten by ESET. What we did is that we open it, we make the recoding, and we close it again. But I just didn't close it again, so we can stop all the processes and we can do anything we wanted to do. We can write registry keys. There's going to be a short demo shortly. Now, the whole thing could not work only with a signed code. The signed code is checked on a kernel level, so if I modify the unlock.exe, it wouldn't work. There's no debugger in it, so if we connect a debugger and we just push that 1 byte in the memory, we can unlock it. And if we stop the process when it is just unlocked, we can again modify it. But from a programming point of view, this is not really convenient. We cannot really do anything with an attack. So if I load a debugger on the machine, on the computer, and then everything stops, a lot of things happen. But what we can do is we can inject codes. This code injection is something that you cannot do with ESET's own program, because there is a whitelist filtering, so it is its own exe is protected. You cannot write it, modify it. The problem is that they are not protecting all of their exe files. There are a lot of tools on their pages which you can download, and these are not part of the whitelist. I just used an easy installer, a Windows installer, the objective of which is to load it down. It gives you a nice window, and it shows you how to install the ESET. Now, the demo is going to be about how to change one single rule, a particular rule. All of the self-protection is switched on, is running. One is an A2 and the other one is an MSO cache exclude rule. There's no any other anything. There's nothing else controlled in that folder. So we try to make the modification here, but it wouldn't, because as I showed you, it would not allow itself to be modified. Then we try to switch off the processes. That's not going to work either, because the EKRN is also protected, and the other processes are protected as well. Yeah, but we have the node installer. We start the launch node installer, and then he says you don't need it because you have the latest version. And then we launch our ESET Campu, which injects the DLL into this process. From this point on, it is running over there, so it has access to the kernel driver as well. We standard IOCTL request, do the registry modification, and we relaunch the process. The user would only, if the monitor would, I mean, if he's watching the monitor, he would just see that there is a flashing of the ESET logo, and there are two bubbles there. But if we mouse it, then it will disappear, and after that, all of the protection is again in place. But here you have the C. So from this point on, no one is checking anything on the computer. You can do whatever you want. And the user would not see anything. It is a seamless thing. The only problem is that I never managed to try it in Sharp, because I never had a customer that was running this one, although I was very happy because I had the solution already. Some information concerning the video. Windows in injection can be done several ways. I use the most simple one. This is standard Windows API. You give them a DLL, and then you tell them what to do. The VM-get message is what we are connecting to. So whenever there is a W32 message coming to the window, it will come to us as well. So this is there in the address line of all of the processes. In our case, I'll just see whether it's an ESET. If it's an ESET scene, then we'll check what we can do. And then we can do a lot of nasty things. This is an easy-to-use API. This is a standard Windows service. I just don't understand how this service was put into the system, because I don't understand why you can use the address line of any other process to manipulate a machine. Now, this is this is when I switch off the protection. The interesting thing was that we had to find out what the device CO control calls were. There are 3 pieces thereof. You can see what the size of the data is. These are very simple numbers that we have to send, and then you don't have to send it again. So from this point on, the whole protection is gone. Now, the problems were caused by the fact that the whole thing was not carefully overthought. The unlock thing probably happened in such a way that the user gave a password to the machine, and then they forgot it. And then they called the customer support of ESET, and then they issued a modified version, an upgraded version, and said that, okay, if you see the register key, you should forget the password. But then they realized that this is not good, because anyone can write a code like that. And also the program developed further. This is how they came up with the registry protection. And then the newer version came up, which lifted the registry protection, and the whole thing worked. The other big problem was that the images that it is checking or letting run to the device hero control file, these are not thoroughly controlled.
Szóval ez csak vicc akart lenni, hogy pingvinnel azért ezeket a dolgokat nem.
Now this was just a joke that with the penguin he would not it would not suck, because here it sucks, but anyway we're on Windows, so we are going to show you what happens. One is the RSA based response code generation. Now the customer generates a code, signs the request, and sends it to the ESET. Now ESET checks it. You can see the license identification, you can see the expiry, so all of the problems could be solved with that. Now you can see whether the license is really valid, whether it's really signed by the user, so validate request and send a signed response to the user. This obviously digitally signed, and then the user's ESET node would have the opportunity to check that, to validate that, to see whether it really came from ESET and whether it really can be used to solve the thing. You don't need to rumble around. And then the other one is the RSA encrypted password. This is encrypted in a certain way and stored. I don't know exactly how they do it. The easiest thing would have been if you could read it from the file, but we couldn't. However, if you wanted to use a public key to encrypt this password, like RSA public key, then you could send this to ESET, and ESET would be capable of decrypting it and sending it back to the user. This would solve the problem to a certain extent, because, you know, expiry and other things are not that much important here. This would be one of the potential solutions. And I also had a chat with the ESET's developer, and they are also thinking in lines of similar solutions. So it's not going to be a digital encryption or digital signature based thing, because as a matter of fact the users keep forgetting this password somehow. However, a digital signature cannot be provided over the phone, and if he had to read a 250 character digital code, that would take a long time, and also that is going to be mistyped, and the response is going to be mistyped as well. This is why we are sending a short code and receiving a short code. Now the next thing is connected to the crypto API, because it is not enough to check the digital signature, because these function names come from Windows. I made a simple program that simply checks the digital signature of each and every running process, and also the digital signature of the modules. So if anyone injects a DLL into my module, that in runtime could be checked whether it's digitally signed or not. This to a certain extent gives you security. My original plan was to tell you the whole thing about this, but it wouldn't take us any further. Checking a digital signature is a 600 to 700 lines, because it is a timestamp, it is the checking whether the certificate is really valid, whether it's really issued for this purpose. So this is quite a complex procedure, and you can quite easily make mistakes during that. The good thing would be to have a simple API in Windows, like for example the function could be called is this exe valid, and not all these things separated together, but a much more simple solution. Normally we don't really need what sort of certificates there are, but if there is a trusted certificate store and Windows has a good one, then all of the data is there. Why we have to open it separately and check the data? I know that sometimes this very complicated maneuver is needed, but not in these cases. And for some reason, this is missing from Windows. This is not only a problem of ESET, but it's the problem of all Windows things, because there are no checking APIs. Now you have the digitally signed programs in Windows, and this as well is going to cause problems similar to the previous one. And we are going to have hacked Windows Store applications 1 or 2 weeks after that will hit the market. The earlier thing is that we are supposed to verify modules and validate all the modules. I have the opportunity in Windows to do so. Module verification, open processes to see what is loaded. If there were hooks and there were code modifications, that could also be detected because you can check whether the image that is on the disk and the image on the memory, whether these so the image in the disk and image in the memory, are they identical? If not, then some sort of modification happened in the system, and then it would be worthwhile and advisable to inform the user about that. But there is no API for that as well. This, in case of rootkits, is something that it works. This method is already widely used there, because there I have a file, and the file content on the disk is absolutely different from the file content in the memory or the file content that the user sees. All of the binaries are supposed to be signed by ESET, and all of the binaries are to be validated, and all of the binaries are to be protected. Now, certain binaries were protected and some others were not. And the ones that were not protected were the installers, because of course if you installed a antivirus program that you normally do not install the same antivirus again, but not everyone thinks along the same lines as ESET and the antivirus people. Thank you very much. That concludes my presentations, subject to your questions. No questions. That makes me very delighted. Thank you very much.